Hey, what's up, y'all? Welcome back to another processing tutorial, this one again on images. In today's video, we are going to start looking at how we can access every single pixel in an image to start doing fun things with all of those pixels. Today's video will deal specifically with how we can kind of make this pseudo slit scanning effect that you can see going on behind me here. So let's get started and take a look at all the code that we're going to need to create this effect. So every single P image that you create and load images into inside of processing has what's called a pixels array, right? So there is an array of pixels called pixels, and you can access each one of these pixels and do something to it or copy it into a new image or whatever, right? You can do whatever you want with it as long as you've grabbed it from this array. And normally, we think about images as being like little grids of pixels. So I drew us a very simple and tiny 12 pixel image here, right? And normally we navigate around this image using X and Y coordinates, right? If X is 0 and Y is 0, I'm right here at this first pixel, right? However, the pixels array is just a one-dimensional array, so we need a little bit of math to help us figure out, where this pixel in this image, X and Y, where is that in my array? And the formula is very simple. It's just X plus Y times width. And let's do a couple just like sample problems here. So let's say if I wanted to grab, pixel number 5 here, right? X is 0, 1, Y is 0, 1. So X and Y are 1, 1 here. For pixel number 5, I would say 1 plus 1 times the width, which is 4, right? So it's 4 pixels wide. Then I get 1 plus 4, which is equal to 5. So that's pixel number 5, right? Now let's try pixel number 8. X is 0, Y is 0, 1, 2, right? So I would say 0 plus 2 times 4, which is 0 plus 8, which is just 8, right? And so you can see this formula is going to give us, based on the X and Y coordinate, right? It's going to give us the pixel that we need from this pixels array. Okay, so let's go back to our code and see all the little details here that we need in order to get this set up. So let's make a new sketch and all of our regular voids set up and draw. We will make our size 640 by 480, and we can make a background. This won't really matter in the end, but let's just, for now, let's make a white background, right? And then I guess I will need to save this, so I can add a picture to my sketch, and we'll call this pseudo slit scan, okay? And now I am going to add an image using the add file option. Okay, so now that's in my sketch folder, I can say, right, here it is. I can say pimage image, right? And in here in setup, I might say image equals load image starry night sky.png, right? And just so we can see what's going on, let's resize this. We'll say image.resize width and height. Now, let's take a look at what this looks like. So we'll just say image 0, 0, run the sketch. Okay, and so here is the base picture that we're going to create our slit scan effect from, right? So now we need to basically access all these pixels and copy them into a new image, right? So let's take a look at how we're going to do both of those things. First, let's get started with creating a new sort of blank image that we can draw stuff onto, right? So I'm going to say slit scan, and here in setup, I will say slit scan equals create image, right? So now I'm going to have like a blank image that's got, basically nothing in the pixels right now, but I can make it the same size. So I'll say width and height, and I need to tell processing this is just going to be an RGB color image, right? So I don't need anything for the alpha channel in this one. It's just going to be RGB. So I also need to just define the color mode that this image is going to operate in, right? So now I've got a blank image, right, that I can copy things into this pixel array. So slit scan has a pixels array. Image, right, which is our sort of starry night sky here, also has a pixels array, right? So if I wanted to start accessing the pixels, I need to say, let me also resize this one. So I'll say, or no, I've already sized this one. Okay, so now to start accessing the pixels in these images, I would need to say image.load pixels, right? And that's going to tell processing, hey, grab that array, grab pixels array, right? And then what I can do is use a for loop, a couple of nested for loops to go through every single image in, or excuse me, every single pixel in that image, right? So if I then say for int x equals 0, x is less than width, x plus plus, right? So for every x position across this image here, x is 0 all the way to 640. Every single column of x pixels here, right? I want to also navigate through the y pixels, right? 0, y is less than height, y plus plus. Oops. Right? So this is now going to navigate through all of the pixels. And what's going to happen is it's going to say x is equal to 0, so it's going to start up here, right? And then y is equal to 0 all the way to height. So the first thing it's going to do is grab this column of pixels all the way on the left side of the screen. And then when it's finished with that, right, it'll exit that loop, it'll exit this loop, and we'll go back. X will be 1, it'll grab the next column, right? It'll finish all the y's, it'll go back and update x. X is now 2, it's going to grab the next column, right? So this set of nested for loops is going through every single x and y of this image in that order, where it's this column, this column, this column, this column, this column, etc., right? Okay, so I've loaded all the pixels from my image. So what I can do is I can say, oh, well, okay, so I'm also going to need to make any changes to the, pixels array for slit scan. I also need to say slit scan dot load pixels, right? So I need to load the pixels for both image and slit scan since I'm going to be operating on their pixel arrays, right? So I can say I want to set the pixels in slit scan, right, at some position equal to the pixel in the image pixel array at whatever position, right? And so if we go back and we say int, let's just say location, right? And we use that same math we were earlier, right, to calculate the one-dimensional position of our pixel. We just need x plus y times width, and that's going to give us the one-dimensional location of that pixel, right? So let's say location equals x plus y times width, right? And then I can now say this is my one-dimensional location for wherever I am, right? In this column, in this column, in this column. This is going to give me the one-dimensional location for that pixel array, right? At this x and y location that I'm wherever I am in my for loop, right? And then I'm going to set that location in slit scan, which is this blank image that we made, equal to the pixel at that same location in the image, right? So whatever pixel I am in this image, I'm going to copy it to my new image. So this here should just create like a copy, right? And for me to have that reflected, I need to update the pixels. So I would say slit scan dot update, right? Pixels. I need to update all the pixels using update pixels like this, right? So now, instead of drawing the image, what I'm going to draw, well, I guess I can just use this same function here. I will say draw slit scan, right? And if I've done everything right, we should actually just see the exact same thing. Yes, okay, great. So now we're basically what we've done is we've just made a copy of this picture, right? We went through every X and Y position one column at a time, and we said, what is that location of that pixel in the pixels array? We figured that location out using our equation, X plus Y times width, and then we said, okay, at that pixel location in the image, right, or in slit scan, set that equal to the pixel that's at that location in our image, right? If I wanted to actually get the slit scan effect, what I would need to do, right, is I would say I actually want to set the location, right, of the slit scan image, right? So all the pixels here, I want that to actually go through every single X and Y, but I don't actually want to change X position of the original images, right? So I want to just grab one slice and copy that to every other pixel, right? Every other column of pixels in my slit scan image, right? So this one, we're going to use the regular location function, right? Maybe what I'll do here is I'll say int location 2, right, equals X position of our scan plus Y times width, right? And we don't have an X position variable yet, so let me do that. And I am going to say int X position, right? And then maybe what I do is up here I can say X position equals map mouse X between 0 and 640, right? And then 0 and width, right? Um, so let's see what this does for us. Oh, because this is all in setup. Duh. Jeez. Okay, so for us to actually do all this, we need to move all of this stuff into draw. Okay, so now when I move my mouse left to right, I'm going to grab a different column of pixels and copy those pixels into my slit scan image. Cool. And from here, we can animate this effect. We can do a few different things. So let's just look at how we might animate the effect first. Okay, I want to not actually do this. And instead of mapping this value, what I will do is I will just, let's say, if X position is less than width minus 1, X position plus plus. Let's just see what that looks like. Okay, so that's kind of moving through this image, and I think at some point it will stop. Right, okay, so now it's gotten through all 640 columns worth of pixels there, right? So if I want to slow that down, I can say something like if frame count modulo, so I don't want it to do every 60 times per second. Let's say frame count modulo like 5 is equal to 0. Frame count is just another built-in processing variable that's going to return the number of frames that have passed since you started the sketch. Okay, right, so that slowed that down a little bit. Maybe I do even a slower speed here. Right, so that slowed that down a little bit. And let's make the scanner bounce back once it's hit that edge. So we will say Boolean forward, so we're moving forward. And we're going to initialize this as true. And we will say if we're moving forward, then do this. And if it is less, and then we'll say if x position is greater than or equal to width, forward equals false. We should be able to come in here, copy this over, change this so as if it's greater than 0, subtract 1 from itself, and if this is less than or equal to 0, then make forward true. Okay, so that's gonna be our counter code. And let's also do another thing that's gonna make it a little easier to kind of visualize what's happening. Um, so let me come up here and I'm gonna say, again, Boolean show image equals false. And I can say here, if show image is true, right? What I want to do is actually draw the image on top, right? And then let's also draw like the line where it's scanning. So I'm going to say stroke 255 so that we have a white line. And then I'm going to say line, again, we're using this X position, right? To grab the columns of pixels. So X position 0, X position height, right? And I think that will do that. Oh, I also need to be able to turn the function to show and hide the image off. So I'm going to say void key pressed. And I'll do something like this. And I'll say if key is equal to the space bar, then switch, what are we saying? Show image equals not show image. So just flip the value of that Boolean. Okay, let's try this again. Okay, so now you've got this, and if I press the spacebar, right, you can see where I am in the image, and you can see what that resulting scan ends up looking like. And so there's that one on the bottom here. If I press the spacebar, you should see that bright one there. Should see this one when I come up on it, right? Okay, and that one went away. There's one right here that we'll see for a second. There's a couple little stars right here that we'll see. Yeah, so those kind of brighten up. So you can see by turning this on and off, it's a little bit easier to, oh, okay, I can see like what part of the image I'm scanning through. Right? And then of course when this gets all the way over here, it'll bounce back. Ooh, there's that big one down there. Yeah. All right, and so this hopefully has shown you how you can use the pixels array of different images that you bring into your sketches to do some really interesting things. Tune in for the next video where we look at how to make another fun kind of glitchy image effect with the pixels array.